Okay, so first reminder, I'm going to look at how to find a nth term for a quadratic or a cubic sequence using your GDC. So you may recall you need to go to spreadsheet first, and don't forget to label your first column n. So these are the terms in your sequence. So the one I've picked has 4 terms. So I'm typing in 1, 2, 3, 4. And then just to match up with your GDC, second column I'm labeling y, and then we put in the actual sequence. So it's 0, 3, 8, 0, 3, 8, and 15. And then I'm just going to click on the blank cell there. But what you should do is I know this is a quadratic sequence, but you should show some understanding here by finding the first difference. So the first difference is going to be 3, then 5, then 7, and then finding the second difference. So as the second difference is 2, it's the same. If the second difference is the same, then we know it's a quadratic sequence. So then you can go to the right place on your calculator. So if we go to that blank cell, then go to menu, you go to statistics, you go to stat calculations, and you're going to pick one of these 3. So it's going to be quadratic regression. Remember, if the third difference was the same, then it'd be a cubic, and you'd pick cubic regression. But this is second difference are the same, so it's quadratic regression. So just click on that. You've labeled your first column n, and then your second column is y, so it just matches up here, and then just click on OK. So we should see here, if I just hover above that it's ax squared plus bx plus c. So we're finding nth term, so we're going to be using n instead of x. But essentially, the coefficient of x squared, or n squared in our case, is a, so that's going to be 1. The coefficient of of x, or n, is going to be b, which is 0. And then the other number here, c, is going to be 1. So if we write that down then, let's do that. So it'd be, as written there, it's ax squared plus bx plus c, but for us it's going to be n instead. So it's going to be 1n squared plus 0n, and I think it was plus 1, wasn't it? Let's just double check. It was minus 1. And that is your nth term for your quadratic. So it's just going to be n squared minus 1. As simple as that. Another reminder is simultaneous equations, so we can do these as well in your calculator. So I've got quite a simple simultaneous equation there. So if I go into calculate, and then a lot of the things you need to be able to use are in algebra. So it's the second one, solve system of linear equations. And then how many equations we got? We've got 2, and we've got 2 variables, x and y. So they match the variables we've got. And then you just have to type them in. So it's 2p minus 3q. So, it doesn't actually, does it? It's 2. Should we change that then? Nah, let's use x and y, it's fine. So 2x plus, or minus 3q, or minus 3y in our case. And then that's going to be equal to, so click on equal, 7. So I've changed the variables here. You could use p and q if we'd spotted that early enough. I'm just not going to change it here. So it's x plus 3y, and that is going to be equal to 2. And then you should just be able to press enter, and there are your answers. So it's 3, x is 3, and y is minus a third. So you're going to have to interpret that then. So x, the first one, so that is p in this case, was 3. And the second one, which is y for us, but is going to be q for this, is minus 1 over 3. So remember, you could change those to p and q. You can type in your own letters. We didn't have to use x and y. Right, here's a reminder just how to use Nsolve. So you can use this to solve pretty much any equation, but remember, it's not very reliable, but sometimes because it only gives you one solution. And there can be some other problems with it as well. So you have to use it with some caution. Again, we go into algebra, numeric solve. So this is quite a complicated one. So I'm just going to type that in. And remember, whatever you're solving for, which in this case is n, you have to write comma that variable at the end. So I'll just show you. Also important, if the things are multiplying together, sometimes it doesn't like it if you don't put in the multiply. So that's 2000 here is going to be multiplied by. So I type multiply and then start my brackets. 1 plus 0.028. So this is from the practice questions that you're going to get today or tomorrow, depending on when you look at this. Right, so that's to the power of n. What are we solving for? What's the missing value? It's n. So I just have to put in a comma, n, and close the brackets. If that was x, we'd put comma x. If we're solving for y, put comma y. And you can only solve for one unknown here. So when we did simultaneous equations, we had two unknowns, two equations. Here we've got one unknown, one equation. And then just press enter. So in this case then, it would be 33.18. And you have solved it. Right, let's move on. So let's look at some quadratic. So we can look at solving these and also equations and also inequalities. So first way I'm going to do this is just by graphing it. So I've got 6 minus 3x squared minus x. So let's graph this first. So I'm going to go back into here, click my graphing and put in the function. I think I'll remove some of these other things. So remember, if you want to delete stuff, you can just go to that cross there. Do I want to save it? No, I don't. And then I'm going to go back into it because sometimes it gets a bit cluttered. So let's type in the function. So it's 6 minus 3x and minus x squared. And let's just press enter. So there it is. So you might want to change the scale a little bit here. It's not too bad. But you could go to here. Let's try and zoom out a little bit. There we go. A little bit better. Right. So in order to solve this, one way I can do it is to look at the x-intercepts here. So reminder then, you're going to analyze graph. Your x-intercepts are 0. And all you have to do is go one side of them to the other side. So that's one solution. Let's do it again. So into analyze graph, you're trying to find zeros. You go to the left-hand side of the second solution. You go to the right-hand side, click enter, and then you got the second one. So that's one way of getting your solution. So it's minus 4.37. And also the other one is 1.37. But recall that you really need to substitute into the quadratic formula or something similar before to show you working out. In order to solve the inequality, this helps make it really, or should help make it really, really visual. So I'm going to cut and paste that graph, and then we can use it to help us solve the inequality. So there it is. Right. So it's where, and a few of you have been struggling with this, so it's where the graph is less than and less than 0 and less than equal to 0 possibly. That's a little bit blurry. Let's say it's this. So we can just confirm our answer. So I'm going to say there's no equal to sign there. It's a bit hard to see. I'm going to write this, and this is what we're going to solve it for. So the graph is less than 0. The function is less than 0. So that's going to be here, underneath this line, underneath the x-axis. This is where y is less than 0. So we're looking here. Where does it satisfy this inequality? Here and here. And we know those key points. That's why this question is linked, because that's 1.37 there, and the other one is minus 4.37. So they're trying to help you. It's a two-part question. So you can use your answer from part A and part B. And it satisfies this inequality then when x is bigger than 1.37, because it's going this way. The x values are getting bigger and bigger and bigger. It's going from 1 to 2 to 3 to 4 to 5 and so on. And then on the other side, they're getting smaller. So you start at minus 4.37, and they're getting smaller and smaller and smaller to minus 5 to minus 6 and so on. So that it satisfies the inequality in that way for those particular set of values. Right. Next thing I wanted to do, I think, is to solve this equation again, but a different way. So recall that we can also use, going to algebra again. So this is where three of your favorite things should be. If you're going to polynomial tools and go to find roots of polynomial, now remember, degree, that's looking at the power of the polynomial. So if the biggest power is 2, which it is, because that's what a quadratic should be, then we don't have to change anything here. If it was a cubic, not that we have to solve those yet, then the degree would be 3, and so on and so forth. But this is a quadratic. So you click on OK, and then you just have to fill in the coefficients. But you need to take a little bit of care here. So the coefficient of x squared is a2. So let's look. What's the coefficient of x squared? Well, it's minus x squared. So it's minus 1 is the coefficient. Remember, when you're putting in a negative number, you have to choose this little negative in brackets. So that's minus 1. Then we look at the coefficient of x. So the coefficient of x is minus 3. So then you've got to go back in, whack it in here. Again, choose that negative thingy button. And last one is going to be 6. So the number without any x's is just plain old 6. So don't, just because they've written it in a different order there, don't let that confuse you. You're looking at what's the coefficient of x squared, what's the coefficient of x, and so on. And then you click on OK, and it fills it all in for you. So all you have to do is enter. Now, hopefully we get the same answers we got on our graph. And yes, we do. So we got minus 4.37 and 1.37 as the two solutions to the graph. Right, one more thing to remind you about, I think, is this. So we're going to look at solving or sketching sketching some lines and then finding a region which satisfies some inequalities. So I'm going to draw in these as inequalities first. So rather than sketching the line, I'm going straight to part B. But I'm going to try this live now. So we're going to, a little tip that Miss Hara actually told me was if we write the inverse of these inequalities, so we use, instead of greater than and equal to here, we write less than or equal to. So you do the exact opposite. It's going to make the region we need to identify a little bit clearer. So let's see, let's give this a go. Right, so we've got to go into graphs again. And I'm going to get rid of all this nonsense that I've got there. And if it will let me, which is not, that's weird. So another way that we can get rid of this is to go to actions and delete all. And that should enable me to delete everything. So I'm starting afresh again. Okay, so let's put in that first inequality. So remember, it's going to be the opposite of x is greater than or equal to 0. So we're going to do x is less than or equal to 0. So let's try that. And let's whack it in. Remember, we don't choose function. So got to try that again. So graph entry edit, we choose relation. Right, so we're going to pop in then x is less than. These are really tiny at the moment, so I'm going to have to remind myself where they are. I think they're hidden here. So if you go control above the equal sign, and then we're doing less than or equal to 0. So we did the opposite. Now I'm just going to press the enter key. So we've done our first little region there. Let's look at our second little region. So the second one is y is greater than or equal to 1. So we're going to do the opposite of that. So we're going to do y is less than or equal to 1. So I'm going to pop that one in now. So let's try that. So again, go to menu, graph edit, relation, and we're doing y is, and we've got to go here again, control equals less than or equal to, I've got to remind myself, sorry, what that is, 1. So again, we've done the opposite. Bosh, got my second one. I only got 2 more to go now, and then we're done with this. You'll be very pleased to hear, I'm sure. Next one is y is greater than or equal to 2. So we do the opposite. Y is less than or equal to 2x. So y is less than or equal to 2x. So let's pop that in. So here we go again. Go to relation. So y is less than or equal to. So we've got to go here again. Less than or equal to 2x. I'm going to put 2 times x, just to be really thorough. I'm just going to check I've done the right thing there. Yep, it's that in reverse, so good, super. And press enter. Now, last one. One more to go, so let's have a little look at the last one. Is x plus y is less than or equal to 5. So again, if we invert the symbol, instead of less than, it's going to be greater than or equal to. So let's try that. So x plus 5, what am I talking about? X plus y is, like that again, sorry. So x plus y is, forgotten it, I'm so sorry, less than or equal to 5. So go back into here. So less than or equal to 5. And then click enter. And there we go. Let's double check. I got all of that right. I didn't. So last one I typed in incorrectly. Let's see. Will I be bothered to edit this or not? Well, we'll soon find out. Right. Okay. So if you want to go back into your graph, you know what? Maybe it's useful. So you can click tab. So if you click tab, you can then work through and find your old graph. So if I click up then, so I'm going to go to this one. I'm just going to change it. So yeah, let's keep this in. And then I've got less to edit. So it should have been the opposite of less than, so greater than or equal to. So let's try that again. So there it is, greater than or equal to 5. And there we go, done. Okay, so what it should do then, why this is better, remember when we did this before, it gets very, 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 very crowded. All the colors overlap. It's really hard to see where the region you need is. But now it's not, because it's that white space there. That should make it a little bit easier. I'm going to remove some of those labels so we can just see the region a little bit more clearly. Okay, done.